Good day to all. In this video lecture, let me discuss about the proximate and ultimate analysis of coal. Coal can be analyzed by two methods, proximate and ultimate analysis. The proximate analysis of coal determines the moisture content, volatile matter, ash content and fixed carbon. It is useful to find out the heating value, that is gross calorific value, and it uses simple analysis equipment. The ultimate analysis of coal determines the components including carbon, hydrogen, nitrogen, sulfur and oxygen. It's useful for the furnace design and it is meant for the laboratory analysis. The moisture content present in the coal. The powdered air dried coal sample is taken in a crucible and weighed. This crucible is heated to 105 to 110 degrees Celsius in an electric oven for 1 hour. After that, it is taken out, cooled and weighed. The loss in weight of the sample is found out and the percentage of moisture content in coal is given as loss in weight of coal divided by weight of coal into 100. Volatile matter present in the coal. The moisture-free dried sample is taken in the crucible, covered with a lid and heated to 925 plus or minus 20 degrees Celsius for 7 minutes in a muffle furnace. The sample is taken out, cooled and weighed. The loss in weight is noted and the percentage of volatile matter is given as loss in weight of coal divided by weight of coal into 100. The ash content present in the coal. The residual coal in the crucible is then heated to 700 plus or minus 50 degrees Celsius for half an hour without the lid in the oven. Then it is taken out, cooled and weighed. The weight of ash is noted and the percentage of ash content is given as weight of ash divided by weight of coal into 100. Fixed carbon. It is the pure carbon present in the coal. It is calculated by subtracting the sum total of moisture, volatile matter and ash content. Percentage of fixed carbon is given as 100 minus percentage of sum of moisture, volatile matter and ash. Significance of proximate analysis. The moisture content reduces the calorific value of coal. It quenches the fire in the furnace and lesser the moisture content, better the quality of coal. The volatile matter also reduces the calorific value of coal. Coal burns with a long sooty flame and it may interfere in the furnace design. Moderate volatile matter coal yields strong coke. The ash content is a non-combustible matter which reduces the calorific value of coal. And ash forms clinkers which puts a fire by blocking the air supply and also increases transporting, handling and storage cost. The fixed carbon, higher the percentage of carbon, greater the calorific value and better the quality of coal. And it also helps in designing the furnace and the shape of firebox. The ultimate analysis of coal, it involves the determination of percentage of carbon, hydrogen, nitrogen, sulfur and the remaining is considered as the oxygen content. Carbon and hydrogen content present in the coal is determined by the Liebig's method. A known weight of coal is burnt in a combustion chamber. When coal sample is burnt in the combustion chamber, the carbon present in the coal is converted into carbon dioxide and this carbon dioxide is absorbed by the KOH tube of known weight. The hydrogen present in the coal sample is converted into water vapor which is absorbed by the calcium chloride tube of known weight. From the increase in weight of the tubes, the percentage of carbon and hydrogen are calculated. Percentage of carbon. The carbon present in coal burns to give carbon dioxide. The weight of carbon is 12 grams and the weight of carbon dioxide is 44 grams. That is, 44 grams of carbon dioxide contain 12 grams of carbon by this equation. And in our experiment, the carbon dioxide which is formed by the combustion reaction is observed by the known weight of KOH tube, which is given as A grams. That is, A grams of carbon dioxide contain 12 into A divided by 44 grams of carbon. And this carbon is present in m grams, and hence we can write the m grams of coal as 12 into A by 44 grams of carbon. In order to find the percentage of carbon, let us find for 100 grams. Therefore, 100 grams of coal contains 12 by 44 into A by m into 100. Hence, the percentage of carbon is given as increase in weight of KOH tube divided by weight of coal taken into 12 by 44 into 100. Percentage of hydrogen. The hydrogen present in coal burns to give water vapor. The weight of hydrogen is 2 grams and the weight of H2O is 18 grams, which means 18 grams of H2O contain 2 grams of hydrogen. This H2O, which is formed in our experiment, is observed by the known weight of calcium chloride tube. And let us consider it as B grams, which is given as B grams of H2O is equal to 2 into B divided by 18 grams of hydrogen. And this hydrogen is present in the coal, which is taken as m grams, and hence the m grams of coal is equal to 2 by 18 into B grams of hydrogen. In order to find the percentage of hydrogen, let us calculate for 100 grams. Therefore, 100 grams of coal contains 2 by 18 into B by m into 100. Hence, the percentage of hydrogen present in coal is given as increase in weight of calcium chloride tube divided by weight of coal taken into 2 by 18 into 100. The nitrogen content present in coal is determined by the Geldar's method. The Geldal is nothing but the long-necked flask. A known weight of the coal sample is digested with concentrated sulfuric acid and catalyst in the Geldal's flask. During the digestion process, nitrogen present in the coal is converted into ammonium sulfate. To this solution is added sodium hydroxide, and then ammonium sulfate reacts with sodium hydroxide in order to form the ammonia gas. This ammonia is trapped and sent into the conical flask, which consists of a known volume of the standard acid. 1 mole of ammonia combined with 1 mole of HCl to form 1 mole of ammonium chloride. Some of the acid is neutralized by the ammonia and some of the acid is left unused. This unused acid is then titrated against the sodium hydroxide solution. So we could able to calculate the unused acid. From the unused acid, we could able to calculate how much of ammonia has reacted with the used HCl. So from that, we could able to calculate the percentage of nitrogen present in the coal. The reactions are given here. The nitrogen with hydrogen and sulfuric acid in presence of catalyst forms ammonium sulfate. The ammonium sulfate with sodium hydroxide liberates ammonia. This ammonia reacts with HCl in order to form ammonium chloride. We know the known volume of HCl, and only some of the HCl is used and some of the HCl is left unused. The unused HCl can be titrated with the sodium hydroxide and we can find the unused HCl. And we know the known volume of the HCl and the unused HCl. From that we can calculate the used HCl. So since 1 mole of ammonia combined with 1 mole of HCl to form ammonium chloride, this HCl is equivalent to ammonia, and from that we could able to find the percentage of nitrogen in coal. The initial volume of N by 10 HCl is taken as V1 ml. The volume of unused N by 10 HCl is taken as V2 ml. The acid neutralized by ammonia is given as V1 minus V2 ml. And we know that 1000 ml of 1 in HCl is equal to 1 mole of HCl, which is equal to 1 mole of ammonia, that is equal to 14 grams of nitrogen. And hence V1 minus V2 ml of n by 10 HCl is equal to 14 into V1 minus V2 into n by 10 divided by 1000 into 1 m grams of nitrogen. This nitrogen is present in the m grams of coal, and hence it can be written as 14 into V1 minus V2 into n by 10 divided by 1000 into 1 n grams of nitrogen. In order to find the percentage, let us calculate for 100 grams, which is given as 14 into V1 minus V2 into n by 10 divided by 1000 into 1 n into 100 by m grams of nitrogen. The percentage of nitrogen in coal is given as 14 into volume of acid consumed into normality into 100 divided by 1000 into weight of coal sample, or 1.4 into volume of acid consumed into normality divided by weight of coal sample taken. The sulfur content present in the coal, it is determined from the washings obtained after the determination of calorific value of coal using bomb calorimeter. Sulfur in coal is present as soluble sulfates. On treating with barium chloride, barium sulfate is precipitated, which is filtered, dried and weighed. From the weight of barium sulfate, the percentage of sulfur in coal can be calculated. Sulfur with oxygen forms sulfate. Upon adding barium chloride, it is precipitated as barium sulfate. The weight of sulfur is 32 grams and the weight of barium sulfate is 233 grams, which means 233 grams of barium sulfate contains 32 grams of sulfur. And in our experiment, let us consider the weight of barium sulfate obtained. And let us consider it as C grams. The C grams of barium sulfate is equal to 32 into C divided by 233 grams of sulfur. This sulfur is present in the m grams of coal, which can be written as 32 into C divided by 233 grams of sulfur. In order to calculate the percentage, let us consider for 100 grams, which is given as 32 by 233 into C by m into 100 grams of sulfur. Hence, the percentage of sulfur present in coal is given as weight of barium sulfate obtained divided by weight of coal taken into 32 by 233 into 100. The oxygen present in coal is determined by the difference method. The percentage of oxygen in coal is given as 100 minus percentage of sum of carbon, hydrogen, nitrogen, sulfur and ash. And ash is analyzed as given in the proximate analysis. Significance of ultimate analysis: carbon and hydrogen. Higher the percentage of carbon and hydrogen, higher is the calorific value and better is the quality of coal. Higher the hydrogen percentage indicates higher percentage of volatile matter. Nitrogen is a non-combustible substance present in coal and hence no calorific value. Its presence is undesirable. Sulfur increases the calorific value of coal. On burning, it produces acidic gases which corrodes the equipment. Presence of sulfur is undesirable in coal. Oxygen, high concentration of oxygen reduces the calorific value, and it combines with hydrogen and exists as moisture in coal. Presence of oxygen is undesirable in coal. Thank you for watching this video lecture.